today we are going to be taking a look at Unit 6A1, which is integration by parts. Integration by parts is a more advanced integration technique. It is actually part of the BC material, and so we'll take a look at it here. Okay, so for integration by parts, it's kind of the pair to the product rule for derivatives. So if you look at something and you're kind of thinking, well, if I was taking the derivative of it, I would have to use the product rule. To integrate it, you would probably use integration by parts. Okay, so integration by parts, you're going to use that when you cannot use U substitution. Remember when we used U substitution, we were looking for the derivative or something that was almost the derivative just off by a constant, and we were able to use U substitution. So let's take a look at a few of these where you wouldn't be able to use U substitution. For example, any of these integrals here, if you're integrating these with respect to x, you won't be able to use U substitution. Notice that they're attached by multiplication, okay? So again, when you kind of think, well, if I was taking the derivative, it'd be a product rule. If you're trying to integrate it, integration by parts might be a good technique. I also just want to remind you up here, the derivative of sine is cos, the derivative of cosine is negative sine, and the derivative of negative sine is negative cos. So remember, when we go down this list, it's the derivative. If you're going up that list, it's the integral. So we might use that today as well. And so integration by parts, I affectionately call it voodoo math, just because of the letters that they use. So this is the actual formula for integration by parts. It says if you're trying to integrate u dv, okay, so these are two separate terms. So notice that these two things are attached by multiplication, okay, just like here, there's two expressions there that are each attached by multiplication. So if you're trying to integrate two things that are multiplied together, what you can do is do uv minus the integral of v du, and that's why I call it uv minus the integral of voodoo, okay? And so you're like, wait a minute, this is a dv, what does that mean? Well, that means that it's something that you know how to integrate, okay? So notice for the formula, you're going to need a du. So whatever you assign to u, you need to be able to take the derivative of. And whatever you assign to dv is something that you need to be able to integrate relatively easily. Because you're going to need to go from dv back up to v for the formula. And you're going to need u and du. So you're like, well, how do I know what to assign for each value? Okay? And so there's an acronym and some tips that I have for you that I'll just kind of scooch down here. Hold on. Okay, so again, dv is something that you know how to integrate, okay, and let u be something that you know how to differentiate, okay, take the derivative of. And make sure whatever the dv is also includes the dx, okay, the dx there. Okay, so the acronym that I wanted to kind of introduce you to, it is, I'll write it out on the side here, so it's L, okay, and that stands for, well, log, okay, so it's L-I-A-T-E, okay, and this is kind of the list for, you know, it helps you figure out what to assign to each. So you have logs, which you might see, and then I is for inverse trig. You might come across that. It's a little bit more rare. Okay, we don't see a ton of it, but it is included there. A is for algebra, aka like any polynomial, so an x squared or something like that. So any algebra or polynomials. And T is for trig, regular trig, not inverse. And E is for exponentials. Okay, so when you're going down this list, you want to choose your u starting at the top. Okay, so if there's a log, you need to make that your u. So like an ln, okay, that would be the u. If there's not a log, if there's any inverse trig, you would make that the u. Then the algebra, then the trig, and lastly the exponential. Okay, and again, because u is something that you want to be able to take the derivative of, and so integrating, you don't know how to integrate ln here, so that means you can't make it the dv, so that means that would be your very first choice for u. Okay, so let's take a look at the example. And so on mine, the type didn't accept the integral. It came out as something garbly, but it was supposed to be the integral of x sine x dx. Okay, so if you have something like that that you're trying to integrate, just make sure that that came out on your paper. I know when I printed mine, it didn't read it in the equation, so it came out as some goofy character. But all right, so here, if I'm kind of using this, remember, if they seem equal, I usually let the u be like the x part, and you can't integrate ln, so that's why you always start with that as your u. But in this case, when I'm selecting the u, there's no log, right? So there's no logs in there, so I just kind of keep going down the list. And so here, algebra, that would be any polynomial. So in this case, that's the x, okay? So I'm going to let u equal x, and then that leaves dv, right, for sine x dx, okay? So remember, when I want to integrate this, now I'm also going to need, for the formula, I also need a du. So I need to say, all right, well, what's the derivative of u? Well, the derivative of that is 1 dx. So just like with u substitution, when we kind of use that little move, we're going to do that again. And then the integral of sine, remember, from the top of the paper, that's going to give me a negative cosine. So v, in other words, is negative cos x. So this is kind of the setting the table piece. And then from there, you might want to remind yourself, I sometimes from here, because this is the integral of u dv dx, so we're going to say that equals uv minus the integral of v du. That's your formula, and you probably want to write that, a bunch of times till that gets ingrained in your brain, okay? So uv minus voodoo, okay, minus the integral of voodoo. So now from there, I'm literally just going to drop these in. So what do we got? It's u times v. Well, I've got my u is x, and v is negative cos x, so I'm going to pop the negative in front. So negative cos x, okay, and then plus, well, it's minus the integral, okay, of v du. So this would be a minus, but remember my v is this negative x, so I'm actually going to factor that negative out. So it's v cos x du, and then that's just a dx. Again, so it's minus the integral of v, but my v had a negative, so I factored that negative out so that I'd have a plus. And du is here, just 1 dx, so that's perfect. So the whole point of integration by parts is that what you're left with, so now hopefully this part over here is something that you know how to integrate easily. So can you integrate this? Can you integrate this? And the answer is yes. I know how to integrate plain old cosine of x. That's easy. Okay, that's the whole point of using this integration by parts, is that on this right-hand side after the integral, you get back to something that you know how to take the integral of pretty easily. So I'm just going to recopy the left-hand side, so negative x cos x, and then I'm going to say plus the integral of cosine is sine x, and of course, because it's an indefinite integral, I'm going to have a plus c on the end. Now technically here you might have, once you integrate here, you're going to have that plus c, so we'll just put it right there. Okay, and that's your answer. You can check this answer by taking the derivative if you wanted, and for that you'd use product rule. I actually have it on the scrap sheet of paper, so I can kind of show it to you real quick. So if you wanted to check your answer really quick, you could. So here's my answer. This would be a double product rule, so you'd say first times derivative of the second plus the second times the derivative of the first, right? So that's the product rule happening right here. And then also this term, you would just take the derivative of that. So you've got first times derivative of the second plus the second times the derivative of the first. The derivative of sine is cosine. And so when you clean these up, those cosines end up canceling, and you end up back with the original. So you can always kind of check your answer using product rule if needed. Okay, let's take a look at another example. Okay, on example 2, again, I'm trying to integrate, and they are related by multiplication. when I try to think about doing u substitution, it's not like it's ln of junk, right, where I would just use a u substitution. It's the product of ln with something. So I'm like, okay, what am I going to do here? Well, I need to use integration by parts. And so with integration by parts, I need to figure out what u and dv are. So one of these has to be u, and one of them has to be dv. So again, I kind of do this as my little acronym to kind of help me figure out what u is. Okay, so if there's a log, that has to be the u. So in this case, ln is a log, so that has to be u. So u equals ln of x. Okay, so that means that the dv has to be the other part. So x squared, and don't forget to include the dx. Okay, so my goal here is to rewrite this as uv minus the integral of v du. Okay, so I'm saying that this thing equals that. All right, well, I've got my u and my dv, so now I need du and v. So the derivative of ln, so now you need to remember how to do that. So the derivative of my u with respect to x, the derivative of ln of x is just 1 over x dx. So you've got 1 over x dx. Okay, and now I need to integrate dv. So if I integrate dv, you add 1 to the exponent, divide by that number. Okay, and I'm going to put the plus c kind of over in there, so you don't need to do that for this. And so now I'm just taking these and I'm dropping them right into this formula. So let's see, this is going to be uv, so it's going to be these two. And obviously multiplication is commutative, so I'm going to put this, so that's uv, okay, minus the integral of v du. So that's this du is 1 over x dx. Now again, before you start integrating things, it's probably worth your time here to try to kind of simplify, do what you can to kind of clean it up. So I'm going to leave this left-hand side of the integral alone, but then over here, there's some things that I can kind of clean up, right? Like this x is going to change that to an x squared, and this 1/3, I'm going to factor that out in front of the integral, because anytime I get a chance to kind of remove a fraction from the situation, I like to do that. So that means I'm just left with an x squared dx here. Again, from this step, especially after you simplify, this part here should be something that you know how to integrate relatively easily. That's the whole point, okay? So if you get to this and you get something and you're like, I don't know how to integrate that, you either picked the wrong u and dv, so you might need to go and switch them, or you might need to use repeated integration by parts, which I'll do an example of, or you're using the wrong integration technique altogether, okay? And again, this unit focuses on different techniques, so if this doesn't work, maybe one of the lessons from later in the week would help. Okay, so now what do I need to do? What am I doing? All right, that's going to be x cubed over 3 ln of x. That part I can't do much with. And then I've got this 1/3. Now I need to integrate this. So add 1 to the exponent, divide by that number, okay, and then add 1 to the exponent, divide by that number, and then, of course, r plus c. And so if this was a multiple choice, they would definitely probably clean it up just a little bit more, okay, so they would probably call that x cubed over 9 plus c as your final answer if that was the multiple choice, okay? All right. Well, that's all examples with indefinite, okay? Well, what if we had a definite integral? So when we take a look at example 3, and again, I'm sorry if that font didn't come up, that character. This is supposed to be the integral from 0 to pi over 2 of x sine x dx. So if you need to make that adjustment, go for it. And so this is a definite integral because I'm going from 0 to pi over 2. The other example, they had a plus c in my answer. That's not going to be the case here. So for this one, again, we're gonna still start it off that same way. It's going to be really similar to, I think, example 1, right? But now we're just going to have a definite integral. So let's see how we do that. So we'll have u is still going to be x, and my dv is sine x dx, right? So just like in example 1, we said du is just 1 dx, and that means that v is negative cos x. So that's just like example 1. Okay, now though, when we go to write our u v minus the integral of v du, we're going to have to put in some additional fundamental theorem of calculus steps. So I'm getting at negative x cos x. Now here's the part though. I've integrated that. It's a definite integral, so I need to evaluate that from 0 to pi over 2. Okay? And then I also have, it's minus the integral, and it's still from 0 to pi over 2 of negative cos x, so I'm going to make that a positive, negative cos x dx. Okay? So you kind of have to, evaluate this piece using those definite integrals, and those bounds just transfer right to the second part. So that's kind of the difference there. So over here, let's see what we get. And I know some people like to kind of apply their fundamental theorem of calculus on this part before they integrate. Some people just recopy this line down and then integrate this, so they do that all in one step. It doesn't really matter. Some might be helpful to kind of clean it up first. So if you wanted to, we can just recopy it for now. So we're still evaluating that from 0 to pi over 2. But then when we go to integrate this piece, the integral of sine is going to be the integral of cosine is going to be sine. So you're going to have plus sine x, and we go from 0 to pi over 2 here. You may see it where they evaluate the whole thing. I kind of lean against that, because if you had to use a u substitution or another integration technique here, the bounds might not necessarily be the same throughout the entire problem. So I would kind of caution against that. And then here, it's just your fundamental theorem of calculus. So you're plugging in the top bound minus what you get when you plug in the bottom bound. So you've got pi over 2, cosine pi over 2, and then minus, what's nice about that, I get a 0 when I plug in 0, right? And then plus, now fundamental theorem of calculus on this piece, so you get sine of pi over 2 minus sine 0. And so hopefully you know your unit circle here, the cosine, right? That's right at the top of the unit circle, so the x value there is 0, so you get 0 times there is still 0, 0 minus 0 is 0, so this whole piece goes to 0, plus sine of pi over 2 is 1, and then sine of 0 is 0. So all that work for a final answer of 1. Okay? So phew. All right, moving right along to example number 4. So let's see here. We're going to do u. We need to figure out a u. We need to figure out dv, and then that'll lead us to figuring out what's du and v. Okay? So again, how do I know that it's integration by parts? Well, that's actually the tough one here, because it doesn't look like product rule right away. So you're like, well dang, like it's just ln of x, and then you're like, wait, I know how to integrate e to the x, but how do I integrate ln of x? And the answer is, you don't really know. So whenever you have to integrate this, you're like, all right, well, I know from that liate, right, that if it's a log, then it has to be the u. So let's try that. And you're like, well, if I make the ln the u, what does that leave for dv? Well, there's a 1 there, and there's a dx. So I guess dv is just the dx part. Well, what does that mean? The derivative of ln of x is 1 over x dx. The integral of x, or the integral of 1 dx is just x. Okay, so follow me to there, give you a chance. Again, this is just an ln of x, so at first it doesn't look like you'd need integration by parts, because normally integration by parts is when you have two things multiplied together, right? That's not what's going on here, but I can't use my other integration techniques because I don't know how to integrate ln x yet. And again, just in case yours didn't come out, it is the integral from 1 to e of ln of x dx, in case you can't see that. So, oops, I gotta scooch this up just a little bit. Sorry about that. And so from there, what do we got? Okay, so we're going to try to use that formula. So we've got uv, So u and v, top and bottom here. So you've got, and I will probably write it as vu so that it's easier. So we'll say that this is x, this thing equals x ln of x. So there's my u and a v minus the integral of v du. Okay, so minus the integral of v, which is x, times du, which is 1 over x dx. Okay, and it's a definite integral, so I need to go ahead and evaluate from 1 to e here and from 1 to e there. All right, well, from here, probably just recopy this part for a moment. And then over here, I can kind of do some canceling, right? Like this x takes out that x. So really what I'm left with is minus the integral from 1 to e of just 1 dx. Remember, my goal was that this thing here was something that was easy to integrate. Yeah, that's pretty easy to integrate if you ask me. So now I just apply my fundamental theorem of calculus. So I plug in this top number, so you get e ln e minus, and then it'd be 1 times the ln of 1, right? And then over here, I need to still integrate this. So it'd be minus, and then, let's see, when I integrate that, you just get an x, right? And we still need to evaluate that x from 1 to e. And so let's see. Just be careful on your simplification here, okay? The ln of e is 1, so then you have 1 times e. Well, 1 times e is just e, minus ln of 1. Well, the ln of 1 is 0, okay? And now I still need to apply fundamental theorem of calculus here, so watch your negatives. I plug in e minus what I get when I plug in 1. So just make sure you're being really careful with those negatives. So you end up with e minus, we'll say minus 0 minus e plus 1, right? If you kind of distribute that, and then obviously this e and this e take each other out. So again, all that work, and my final answer is 1. Guys, it's just a coincidence that those both ended up to be 1, but we've got there. Okay, so that is several examples there. I think I've got a couple more examples moving forward. So let's take a look at example 5. Okay, all right, when you look at example 5, be careful, be careful. So hopefully when you're looking at this, you would realize that those are not attached by multiplication, that this is just, x minus cos x dx. And so this is not an example of integration by parts. This is not integration by parts. I think that's what's tricky, is sometimes you get kind of far enough in your calculus career that you have all these tools, so you get like, really married to one integration technique. And the hard part is when you now come across a problem. I used to give you ones where, it was either going to be, just add 1 to the exponent, divide by that number, or it was going to be an easy u substitution. And the tricky part now is that each problem you're going to have to really examine and decide which integration technique is correct. So this, you don't need to do very much here. This is just a regular old add 1 to the exponent, divide by that number. Because remember, we are allowed to integrate term by term. So we integrate this. And then, careful, that's a minus cosine. So when you integrate, you get a negative sine x. And it is a definite integral. So we need to go ahead and evaluate from 0 to pi over 2. Fundamental theorem of calculus says you plug in pi over 2. So you get 4 pi squared over 2 minus sine of 2 pi. And then minus what you get when you plug in 0. Well, there you get 0 minus sine of 0, which is actually 0. So when you finally clean this all up, I think you just end up with something like 2 pi squared. Okay, there you go again. So that is not integration by parts. That's just a regular old integration. Let's take a look at 6 and decide which integration technique will work here. So, well, I see two expressions kind of multiplied together. It's not a u substitution because the derivative of this, if you were saying u sub, you'd be thinking, all right, well, this is the derivative of e to the x. The derivative of the x is a 1. That's not going to help me here to get quote-unquote get rid of that x. So this is integration by parts. So that means that I need to figure out what u and dv are. Okay, when figuring out what u and dv are, we kind of use that LIATE. So is there a log? The answer is no. Inverse trig? No. There is some algebra, just a plain old x, like a polynomial. So we let that be the x, or let u be x, and that means the dv has to be the rest, which is e to the x dx. Now I take the derivative of u, so du is 1 dx. V is e to the x, because if I'm trying to integrate e to the x, if it's just a plain old e to the x, then the integral is just plain old e to the x as well. There's no u substitution or anything needed. So we get to there, and so now we're going to say this thing equals uv minus the integral of v du. If you need to write that, uv minus the integral of v du, write that out a few times till it really, sticks in your head. Okay, so it's an indefinite, so that's fine. So we get to here, we just plug these in. So it's going to be x e to the x minus the integral of v du. So these two. So that's just e to the x dx. Okay. Again, when you get to this step, your eyeballs are really focused on this, and you're kind of saying, do I know how to integrate that? If the answer is yes, then you're like, all right, I'm feeling really good. Like, I'm probably doing this right. So I just recopy this part over here, and the integral of e to the x is just e to the x. Watch that negative sign. And so my final answer, don't forget your plus c's. There's my final answer. Okay. So now, what happens when, it doesn't work? When you get to the part and you're like, ooh, there's a problem. So this one, again, my integrand didn't come out there. All right, so it's another indefinite integral. And so write a little bit smaller on this one because you're going to need the extra space. So I'm going to say u, there's no log, there's no inverse trig. So u becomes the algebra part of the polynomial. So that's the x squared. Okay? So that means that dv has to be the other thing, which is e to the x dx. Okay, so far so good. So then I say, well, the derivative of u is going to be 2x dx, no problem. And then v is going to be e to the x. So it kind of starts off the same way. And so again, I'm going to say this is going to be uv minus the integral of v du. So I go to try to write, I kind of go and I plunk these in. So you get u and v, okay? So you have x squared e to the x, no problem, minus the integral of v du. So I'll write it as 2x e to the x dx. Okay? Well, from here, even after we simplify it, so we could say, right, so we can simplify this just a little. I would probably pull that 2 out, so you've got minus 2, the integral of x e to the x dx. The issue becomes, well, how do I integrate this? And you'll notice, well, that's another integration by parts. So you need to do integration by parts again on just this piece. Okay? Now, don't forget, you've still got this piece over here. So some people kind of do it as like a scratch work, or they'll just recopy this in front and then do it. So I'm going to do the integration by parts of that again. I'm going to kind of write my u and stuff over here just because I've got some space. So on this piece, my u is going to be x. That means that dv is going to be e to the x dx. Okay, so that means that du is 1 dx, right? And v is e to the x. So I'll try to, maybe I'll keep it color-coded, maybe that'll help. So when I go to write this, I'm going to say this equals, I just recopy this left-hand side, okay, minus 2, so that part's okay. But now I'm going to have a big old set of parentheses here because now I need to kind of do this. I have to kind of do another integration by parts. Okay, so I'll kind of switch colors. So now it's going to be, again, that uv. So here's uv. So you've got x e to the x minus the integral of v du. So here's v, and then du is dx. So e to the x dx. Okay? So you've got this going on. Here's the good news. Now this part here is something I know how to integrate relatively easily. So you can kind of go ahead and clean it up. And so we would say x squared e to the x minus 2, and then I would say x e to the x. The integral there is just going to be a negative e to the x. And then, of course, we'd have a plus c hanging out. So you could, if you wanted to, distribute this negative 2 if you wanted, or you could leave it either or. Okay. Just be on lookout, especially if it's multiple choice, if they distribute or kind of clean it up in there. But yes, that's an example. You might want to make yourself a note. This is an example of repeated. That's what they call it. So repeated integration by parts. That way you know you have an example in case you need that for later. So that one's going to be repeated integration by parts. Awesome. So we are moving right along. So here's just kind of a quick little, I wanted you to kind of match which integration technique you would use. So you're just basically, you're not actually doing the problems, you're just kind of saying, well, what integration technique would I use? So for example, on this one, to integrate secant squared, well, remember the derivative sign is cos. Cos is negative sign. Tangent is secant squared, right? So to integrate secant squared, that's just an identity. So you would say that's an identity, okay? And for this one, these are two things that are multiplied together. I can't use u sub, so that's going to be integration by parts. So go ahead, pause the video maybe, and see if you can kind of identify the correct technique. Okay, hopefully you've had a moment there. Number 3 was definitely u sub. Again, you could take this and write it to the 1/2 power, right? So it becomes the square root of junk. So that's going to be u substitution. Number 4, that's going to be an identity, right? Secant itself and tan. So then we've got another u sub for 5. 6 will be integration by parts. 7 is going to be a u substitution. And 8 is going to be integration by parts, actually. So you might have to do integration by parts twice. I think that would actually be a repeated. But okay, so that's kind of the lesson. I did have one other thing. So below are 4 different ways. So if you kind of go all the way down, hopefully you have something like this. I really wanted you to be able to kind of take a look and examine how integration by parts might be tested on the AP exam. A lot of times it shows up as a multiple choice question, and they might kind of do it in these different ways using a table. They like to do it. So I want to take a look at these for just a minute. So whenever you see a table that kind of has that f, f prime, g, g prime, there's a lot of different ways they can go with it. Now here, they're telling you if, and you have an integral, and you've got notice how it's f and it's a g prime. It's not f and f prime next to each other, okay? It's an f and a g prime. And they're asking you for, what's going on here, and you're like, what the heck is going on? This is actually an integration by parts, kind of undercover, okay? So there's like an undercover integration by parts. Hopefully what you'd realize here, so you've got this original, right? Then they're asking you what this equals. So basically your goal is to kind of figure out what is u, what is v, what is du, what is dv. So I think that it's helpful to kind of write down the formula. Remember, when we are trying to find the integral of u dv with respect to x usually, right, we say that that's going to be uv minus the integral of v du. Okay, so here's the trick in these problems. When they give you this part, like they're telling you that this hot mess is 6, that's usually this part here, because they're going to try to like eliminate that tricky part for you. So you need to kind of say, all right, well, that means the derivative part, this part must be the du, and this is the v. Okay? So once you kind of figure that out, maybe like rewrite it and see, rewrite it and then try to plug in using the table. So from here, let's just kind of state what the stuff is. So I'll kind of do it over here because I've got a little bit of room over here. So again, when they give you this, that tells you this more complicated part. So in this case, they're telling me that v is f of x, and that means that du is g prime x. Well, what does that really mean? If I know v is f of x, that means that dv is f prime, the derivative. And if the derivative is g prime, that means that u, right, was just g of x. So now you're like, okay, what are they really saying here? They're asking, what's the integral of dv, of u dv, because they just wrote it in a different order. So this is really the u dv. So this is asking you to do this, okay? So from here, this is, and it might be easier if you kind of labeled them. I would probably label them. So I would say this is the u, and this is the dv. And normally we write it as u dv instead of, here they wrote it as dvu, but it doesn't matter. Now we just need to rewrite this part of the equation, okay? So we're going to say that it equals uv, and again, I wrote it out here because that kind of helps me. So it's uv, so uv minus the integral of v du. So v du, and then I'm going to go back and make it was a definite integral, so this was from 1 to 5, and this was from 1 to 5. And then you could go plug in, apply your fundamental theorem of calculus, and then here you'll be able to replace this whole part, and then use the table. So here, it's probably going to take me 2 lines of work. Hope I have enough space. So if I apply my fundamental theorem of calculus here, it's g of 5, f of 5, minus what you get when you plug in 1. So minus g of 1, f of 1, okay? And then this is the nice part, minus, well guys, they told me that the integral of f g prime, right, from 1 to 5, they told me that this whole thing is a 6. So that's what's nice about this. They were letting you kind of drop that in. They were giving you the complicated part. And now I just need to use my table. So then you'd say something to the effect of, well, g of 5 is negative 1, so you've got negative 1. F of 5 is 2 from the table, right? So f of 5 is 2. Minus, just watch your parentheses. So you've got g of 1 is 3 times f of 1 is negative 2. And then you still have this minus 6. And then, yeah, you're just going to have to kind of clean that up. So you've got, what, negative 2, and then this gives you a negative 6, but it's a plus 6, so those cancel. So I think your final answer just gives you a negative 2 all day. So just check my arithmetic there. But that might be one way that you see integration by parts tested as a multiple choice question. That's kind of tricky. So walk through that one again and kind of make sure you know what you're doing in that example. And once you kind of get your head wrapped around there, we could take a look at it given a graph. I did borrow a couple of these questions from Brian Passwater. He shared those with me, so I will definitely give him credit for that. So that was given a table. Now let's take a look at given a graph. Okay. So again, these are all kind of like different ways that we can look at these integration by parts questions. So hopefully you can kind of see that. Hopefully it came out okay on yours. But I'm going to walk through this one next. Okay, so take a minute and just look through that problem. So you've got 3 different graphs, okay, and then there's definitely some points. And it's asking me to integrate. And again, whenever you see f and then you see some other derivatives in there that's not like f prime, that's kind of an integration by parts. So when I'm going through this, what I'm thinking in my head is, well, this is probably the u and this is the dv, okay? Because this is something that I want to be able to integrate, so that would be easy to integrate. If I'm given the second derivative, right, and I need to integrate, it's just going to be the first derivative. So I would probably kind of off to the side say, all right, I'm going to say that u is f of x, and that means that du would be f prime x. And if I'm saying that dv is g double prime of x, that means that v is just g prime of x. And this makes me feel okay because I've got, g primes and things. So when I go to rewrite the equation, right, when I go to kind of rewrite it out, think about what you'd end up with. You'd end up with, so it's uv, right? So I've got u and v. So you've got, I don't have enough room. So we'll say f of x, g prime of x, evaluated from 2 to 5, that was given, minus the integral from 2 to 5 again, of, then it's v du. So in this case, that's g prime of x, f prime of x. Okay, let's see what we can do with this. Well, we can, if we apply our fundamental theorem over here, right, you end up with f of 5, g prime 5, minus what you get when you plug in 2, so that'd be f2 minus g prime 2, okay? And then you've got minus, well, what am I going to do with this part over here? Okay, so you got to say, all right, what am I going to do with that? Well, good news. They gave me something in the stem. It says if f prime is 4. Well, look, if this f prime is a 4, then I'm just going to pop that out front, right? So that's really just going to be 4, the integral from 2 to 5 of g prime of x, okay? And now g prime is very easy to integrate. I would just get back to g of x. So, well, I guess I can kind of clean this up. So f of 5. So you just have to be careful on this f graph. You would see f of 5 looks like it's 17, right, from this point here. So you'd have 17 times g prime 5. So here's the g prime. So g prime of 5 is a 4. So you get 17 times 4. And then minus, watch your parentheses, I'm going to do f of 2. So here's f, that's this curve. So then f of 2 looks like it's 5. Okay, so f of 2 is 5 times g prime of 2. So now I'm on the g prime curve. G prime of 2 is 1. Okay, and then minus 4, and then I'm going to do a bracket there. So then I'm going to say, all right, when I integrate g prime, I would just get to g of x, but now I need to evaluate that from 2 to 5 as well. So I'm going to continue to kind of clean up. I'm being very bad with my notation here. I don't have any equal signs. Yikes. Okay, so let's see. 17 times 4 is what, 68? So 68, hope my math is right there, minus 5. It's cleaning up. And then it's going to be minus 4 parentheses g of 5 minus g of 2. Start scrolling this on your walls at home, see what your parents think. All right, let's see. So that gives me what, 63. So I got a 63 minus, and then 4 times, let's see, g of 5 is what? So g, so it's this curve, g of 5 is 9. Okay, that one's kind of hard to see. So that'll be 9 minus g of 2 is 3 right there. Okay. And so let's see, 63, and then 9 minus 3 is 6. 6 times 4 is 24, so 63 minus 24. I think that's going to give me a 39. Whew, yikes. Okay, so that's given a graph. And then another way that they might ask you about this is given the partial setup in the answer. So they kind of give you the expanded form, and then they're asking you to kind of go backwards and say, well, what was it, if I would have, written this out more condensed? Or it's basically saying, do you know if you can figure out what u dv, right? So what would the expanded form be? So again, when in doubt, I always kind of go back to that. The integral of u dv equals uv minus the integral of v du. Seeing it written out like that really kind of helps me play the match game. Okay, so you're trying to figure out what was u, what was v. So in this case, u is f of x, so we'll say if u is f of x, and if, say you try u is f of x, and then you go to write it out, and it doesn't work, then just go back and switch them, okay? So you've got this, so we've got u dv, that's this, right? That would be u dv, and then, let's see, does that match? Is it u v minus the integral v du? So notice that it switches from a, normally it's a minus sign, but it's a plus. Well, that's going to happen because remember, the derivative of sine is cos, but when you're integrating, you get back to that negative. So you'd have, let's see if I kind of cleaned this up, du is going to be f prime, right? The derivative of prime of x, so you need that. And then v is going to be negative cos x. I'll just write it up here, v equals negative cos x. So what are you going to end up with? You're going to end up with uv, so f of x minus cos x, right? So you're going to get that negative in front, just like there, minus cos x. So that part worked. Minus the integral of v negative cos x dx. And then you've got that negative is going to pop out and make that a positive. Oh, and I still need an f prime over here. Okay, so that is going to give me, and so they're telling, well, look at this. They're kind of giving me this. So basically, what you need to say, well, if f prime of x is 4x cubed, what was f of x? Well, what do you need to do? Add 1 to the exponent, divide by that number. So you'd get 4x to the 4th over 4, which just leaves x to the 4th. Now, technically, there's a plus c there. So this would be, it might say, like, what was f of x? Remember, we don't really know what f of x was until we see this part, and you have to kind of play the match game, like what goes to where. So once you factor that negative out, you're like, okay, this f prime of x had to be this 4x cubed. So it's kind of this like weird little matching game. Okay? All right. And what do we got for the last one? So a twice differentiable function. Oh, this time it's just kind of giving you the value. So it's going to be a very similar setup. See if you can try to figure this out. I'll give you the hint in this one. So let's make this the u and then the dv. So I would pause the video and see what you can come up with to see if you could crack this one. Okay, hopefully you've had a moment and you went through and kind of applied that same technique there, and I ended up with a -8. So this video ended up a little bit longer than I intended. So hopefully you were able to do that. I will have additional videos, I think, for the homework for this section. So if you still needed some extra help, I would kind of look for those additional videos. But I'm going to cut this one off here. Thanks. Have a great day, guys.